join us on the stage. We'll also have a keynote address by Mr. Gurvinder Chohan, CEO and founder QSTC. So please join us on stage. We also have Suyash Singh, CEO and co-founder Galaxeye, as a speaker. While we wait for him to join, we'll begin with the session. Cutting-edge technologies, materials, and manufacturing processes are revolutionizing the way spacecraft are built, making them lighter, more efficient, and capable of achieving ambitious missions. As the industry continues to push boundaries, spacecraft design and manufacturing will play a critical role in shaping the future of space exploration and utilization. That is what we will be exploring in this session. And on that note, I would like to hand it over to Rajiv, sir, and begin the session.
Thank you. Good afternoon, ladies and gentlemen. We have now just finished our tea, so we are rejuvenated, and we have waiting for another mindstorming session here. So ISRO, per se, we have started the building and launching of the satellites, and we have seen a paradigm shift in the technology, not only in the design of the spacecraft or satellites, as well as in the production of it also. We started, actually, that concept was a multi-utility satellite, so that, and its life should be a longer life also, like that it should have a life of 10 years, 15 years. And we basically concentrate on the geo orbit, so that we will be able to have the maximum utilization of the satellites. But if you see that in last 10 years or so, there is a shift, a gigantic shift happened in that field of utilization of the LEO orbit, where most of the satellites we are now targeting to be placed in the LEO. So that concept for a satellite also has taken place, total 360-degree change. We have different size of satellite, we have a different weight of satellite, we have different shape of satellite, and functionality. We are targeting only for certain function to be operated by the satellite. We are not very much interested in going for multi-utility satellite. That's why the design also has a total change. Now, as we know that 1 kg of material taking it to the orbit is really costly, so design also has changed. We have now shifted because of advent of AI as well as in the computer. We are able to have an organic design, where we are able to utilize a single gram of material, whatever actually we need, only we need to fabricate, so that the weight of satellite can be brought down to that minimum whatever possible. Similarly, the material has also changed. We were earlier having a standard classical type of material, aluminum and steel and all those things we were using. Now the advent of all composites, then 3D printing, additive manufacturing, they have brought a different type of material which are lighter in weight, are able to give a very high strength, as well as they are actually cheaper when you really go for the production of the satellite. Similarly, the process also has taken a total change. Earlier, like that, we were basically doing on the classical mode of machining, making the component, assembling them. Whereas now we are going for totally like a different change, like 3D printing we are using, where the number of components are also coming down. We are able to get a higher efficiency at lower cost. As well as we are able to get that benefit of different shapes we are able to make it, different contours we are able to make without actually spending more money on the realization of the contour. Automation also is one part which has really entered in that space field and really helped us to make satellite. Earlier, like if you say one satellite conceptualization to realization used to take 2 to 3 years, even sometimes more than that period. But now, due to the automation and due to the new innovative techniques in the design and production, the realization time of satellite is very less. Within like 3 months or 4 months, we are able to realize the satellite and launch it. So we are at now crossroad where we are really looking for the future, where we will be making satellite as on demand and launching it within the period, because now time is very short. The technology is changing very, very fast. If suppose we are not keeping pace with the technology will surpass us and we will be left behind. So we have to meet the challenges of the change in the technology. So I think this session will be very, very beneficial to all the audience sitting here. And we have Mr. Gurvinder Singh from the QSTC, as well as I am waiting for Suyash Singh from Galaxeye. They are also in the field of production of satellite launch, etc., and utilization of their services. So I hope this session will be very useful. And now I leave the stage to Mr. Gurvinder Singh to come and deliver a keynote address, as well as then we will wait for Suyash to come, and then we'll have a panel discussion afterwards. Thank you very much.
So before I start, I just want to have a little introduction and what we do, so it gives you a context what we're going to talk about. So here you will see a different type of solution from Geo, MEO, LEO, defense, remote sensing. And before I start my presentation, one of the key question, what I think everybody will have, what satellite manufacturing has to do with the social economic impact and benefits, which is the theme of today's conference. So I'm sure you might have heard since yesterday morning and today that satellite play a key role in today's life. So that means each and every aspect of our life is being impacted by the satellites today. If you look at today, there are millions of lives being saved by the satellites due to the surveillance, due to the in-time information on meteorological, weather conditions, whether it's a tsunami or any type of a prediction which is being done by satellites. And on top of it, then we have communication systems, and today with the advancement of technology, you get all the information on your fingertips. And this is all possible due to the satellites what we have today. So satellite do play a very, very key important role in our socio-economic development in today. So with that context, I'm going to wait until my presentation finish, then I'll go start where we started the satellite or space industry actually. So these are the projects which we have been involved with the International Space Stations. We did a lot of projects for space station. We are doing some lunar missions. That's we're going to talk about deep space missions. We did a lot of payloads for JAXA, Japanese Space Agency. We are doing some projects for NASA, European Space Agency. And currently we are also working on a lunar train vehicle for NASA, which will be used by astronauts in 2026, where they will be driving the vehicle on the surface of the moon. And we are providing the communication system, optical and RF from moon to Earth via gateways or via RF directly. So this is also one of the novel technology what we have is in-orbit services, like in-orbit refueling services. It's not a real refueling, but it does the extension of the life. So this gives you a synopsis of all our orbits to what kind of a satellite manufacturing we do, starting from LEO all the way to the deep space missions. With that, now I'm going to address the key question today, the satellite manufacturing. So let's go back a little bit. 1962, when very first satellite, Alouette, was launched. And I'm proud to say that my first company, I was involved, and we were part of that to build the components and RF systems on that satellites. So I have been, as a heritage, part of the very first satellite from 1962s. And then 1971, when ISRO had the first satellite from Ford Aerospace, INSAT. And that was also one of my company, when we provided that satellite in 1971, when we did the technology transfer, and then we had ISRO team in SAT-1 based in Palo Alto to get the technology transfer, and then laid the foundation stone, what we see today, the development of projects. Going on further now, since last, let's say give and take about 7 to 8 years, we have seen a tremendous improvement and changes in the satellite industry. Specifically, as sir mentioned, a lot of things which I was going to cover, like additive manufacturing, the 3D printing, as well as light materials, propulsion systems. Now we are talking about, no more talking about chemical propulsion, we are talking about the green propellant. If we are going to use the green propellant and it's environment friendly, then we are talking about the lighter and lighter electric propulsion systems. And even there are some companies who are working on water propulsion system, on water-based propulsion systems. So going back to the satellite manufacturing. So currently, for us, we have been doing some satellite R&D for last about 3+ years. So I can easily say the satellite which we used to have like a 4 or 5 ton class satellite a couple of years back or 10 years back. And today we have 450 kilogram satellite, which can give the same throughput or more throughput. Today we are building one satellite for an operator in Southeast Asia, and that is about 525 kilogram, but giving a throughput of 160 gigabit in Ka band and QV. And cost-wise, if you compare the cost, like Viasat, I don't know if you know, anybody you know, but 80 gigabit when they launched about 10 years ago, that costed about $500–600 million. And today, you can get that fraction of a cost, like 1/10 of a cost. Like you can get the similar satellite for like less than 60 million in orbit. So what happened? That a lot of things happened. First of all, the technology evolved, the metal. We are no longer using the honeycomb sandwiches. Now we are using carbon composite or other composite materials, lightweight materials. Secondly, we are using more and more software-defined systems. That's another next generation of evaluation of the satellites. Like we are doing, eliminating many boxes. Like those who are familiar with the spacecraft construction or architect, you know, there are payload interface units, you have avionics boxes, then you have electric interface units, then you have avionics boxes, then onboard computers, then you have star trackers, then you have all the interface units for each and every box. That increases the mass. So what we are trying to do, we are trying to eliminate all these boxes to have only one standard box which does all the interfaces for each system and subsystems, thus reducing the mass and giving more efficiency. Plus, it provides double, triple redundancy that makes it fail-proof. So these type of things which are happening, which we are doing, and that's helping to evolve the industry today. Now next generation satellite will come. There are a lot of industry players, which I know. They are working what we call S-Lego. I am sure you are aware of the Lego system, like the building blocks. So they are launching the building blocks in the space. They are the base projects, base platforms. And in the space, you can combine different blocks to make a bigger satellites. And at the same time, you from the ground, you can inject or eject the new payloads. That means you are no longer a particular defined one satellite, one payload type scenarios. Now you want to augment the capacity, just add another payload, or remove that, add another payload. So these things of evaluations are taking place. And finally, we are part of the Berlin University. And in that, I don't know if you are aware of a Manufacturing 4. Anybody heard of Manufacturing 4? So Manufacturing 4 is as Sir had given a little hint, that we are working on robotics, artificial intelligence-based manufacturing systems. So what does mean? We already have a proof of concept where all the satellites are manufactured automatically on assembly line. I don't know if you remember many years ago, 10, 20 years ago, we used to watch the Maruti Suzuki cars being automatically with the robotics arm on this assembly line. So similar line is being created. So we have a table. On the table, you have a different of components and subsystems. The solar panels are lying one side. There is a robotics arm, which is pre-programmed, which picks up, does assembly, and then there's a laser measurement systems, which does each and exactly measurement of each and every component, where it is placed. And there is a checkout done. So there is no human intervention until the last point when you have to move it out and do the final checkouts. So with that, currently we are estimating that by next year, we will be working about 50 to 70 satellites per year of about 75 kilogram class. And if you want to do the small CubeSat, like a 16U or 20Us or small ones, that you can go up 200, 300 satellites per year. And the similar concept is being now implemented by Leicester University in UK, which we are also part of that. So that Leicester space is going to come online by September this year, which will have a first prototype of this automatic assembly and manufacturing. Next week, I will be going to Hong Kong. And in Hong Kong, there's a association they call Hong Kong International Aerospace Association. So they are claiming that they are going to be first robotics manufacturing company in the world, where they will be producing 200 satellites every year. So this is what we are talking about, next generation evolution of the satellite and technology, what's going to taking place. So how do we tackle, how do we handle this type of technologies? Do we have enough demand? That all depends on the regulatory bodies, customer requirements, as well as the commercial aspects. Like, is there enough return of investment to do this So they both have to go in parallel, like a technology involvement as well as the commercial aspect of the satellites. Now, the other aspect is that now we have 3 different type of orbits, like as Sir mentioned, LEO, MEO, and GEO. So from LEO, right now you can imagine that we have a 0.5 U, just the size of a sandwich, a bread toast stand, that type of satellite, which can give you a IoT capabilities. That means with the IoT, you can have track all the type of assets, for example, in the railway assets or any type of valuable assets which is being tracked either via ship or sea or by air. And with that, you can have a temperature control, everything you can monitor via IoT. So these are the damn cheap satellites. And launch is cheap. Now next level you go. Now we are talking about different type of constellations, like you hear about Starlink, you say OneWeb. So OneWeb goes to a little bit higher orbit, like a MEO orbit, and Starlinks are there. Then there is Azure or from Amazon. They're talking about 60,000+ satellites. And then we have a Telesat, and they're also talking about 400+ 280 satellite and going to 400 satellites. But if you look at the Telesat satellite, they're talking about 450 kilogram satellites on a LEO orbit. So before that, it was not a conceivable. Everybody was thinking, oh, it's too heavy. We don't work in LEO orbit for such a heavy satellites. These satellites usually go to the GEO orbit or higher orbits, where you have that capability of providing Wi-Fi and all these communication links. But now Telesat is doing on the LEO orbit. So similarly, if you go to a little bit higher in MEO orbit, and the MEO orbit, now everybody is talking about different constellations. There are different constellations, different materials, and how we make it more efficient. So they are talking about different 8 cluster of 8 constellation of covering all 8 areas, geographical area in the world. But each satellite will be providing the same functionality. So the satellites which are manufactured are offering a much multitude of lighter weight, more efficiency, and more powerful softwares. Now comes the design life. Now we used to talk, we started from 5 years, then we went to 7 years, and now whenever I get an RFP or RFQ from anybody, they talk baseline of 15, design life of 18 years. That's what they talk, minimum 18 years of design life. And now we are talking already about 20 years. We are saying, okay, you asking 20, 18, we are offering you 18 design life, 20 years as a design life. So now you can see that in order to achieve this, we have to done a rigorous testing. Mostly main key important factor is the electronics, onboard electronics, and the fuel. Those are the 2 things which makes the life of a satellite, unless until there is some solar flare or something happens which we don't control. So otherwise, these are the aspects which we are talking about right now, looking at the future, how we can do. Then we are also working on some of the projects for deep space missions. We are talking about going further than Mars and this and that. And I have been part of what they call LSIC, Lunar Surface Innovation Committee. And one of the aspects of that is to develop new technologies for onboard fuel for the satellites. So onboard fuel, now we are talking about non-radiative fuel, not the radiative, but non-radiative fuel, where you can generate, it's like a nuclear power plant, but it's a non-radiative. With that, you generate not kilowatt, but megawatt of the power, where you can run your satellite forever You can go as far as you want to go without any loss of power or anything. So these are the future things which we are talking about. And yesterday I was just reading an article somebody sent to me, which I find very interesting and exactly opposite what we are doing right now, is that ISA or NASA, they approved some funding to do in-space robotics manufacturing. That means we will launch a satellite or base station, and then in space you can do the robotics manufacturing. That means there will be additive manufacturing there, and there will be robotics arms in space where they can do the assembly in space. So you can do the reconfiguration of the satellites in space. So these are the next generation we are talking about coming from now to 5 to 10 years, which you will hear it. So now there's no more question of like having a 2-ton, 3-ton, 4-ton satellites. Now we are talking about less than a ton satellite or 400, 500 kilogram class satellites, but giving them much more efficiency. And then let's talk about the impact it has on the socio-economic development. So as the price of the satellites goes down, obviously the benefit goes to the end user. So now, due to this advancement of technology and satellite manufacturing, changes in the satellite manufacturing, now we have seen the couple of years back, the per megahertz bandwidth price was $1,000 plus, and now you can get $500. Or even some are offering like less than $100 even, depending on what type of, say, LEO or GEO, what type of configuration they have. So these are the directly or indirect benefit to the user of development of these technologies in space for the satellite manufacturing. So as you can see that there's a clear roadmap from the industry and from the government to do a lot of innovation in the satellite manufacturing, and there's a lot of roadmaps being created by different organizations. And end of the day, result is to provide benefit to the end user. And at the same time, we have a lot of R&D going on for doing some medical research in the satellite, how these satellites can be used for the medical usage. And at the same time, there are a lot of work being done on the satellites, the components, subsystems, and they can reduce the mass. So in bottom line, I think we have done a lot of achievement in the last 5 years, which was not possible before, and it's all due to the electronics. We are coming up with the new software-defined radios and ultra-light materials and additive manufacturing and innovative ideas. That's the key, innovative ideas. Ideas come from you guys. It's not from us or from me. It's all you guys who come up with ideas and tell us, hey, this is what I would like to see. Most of the time, it's a customer-driven requirement. Customers say, hey, I want to have a 500 kilogram satellite, but I need this result. So that compels the industry to do the R&D. Otherwise, industry is always happy what they are doing. They say, okay, I'm happy, I'm doing, I have customers, I keep on repeating the same thing. But when the end user start asking us, then we say, okay, yes, we can do this, we can do this. So I always stress to the customer, guys, you come up with something, challenge us. We are the manufacturer, we have the R&D, we have the brain. We can provide a solution, but you tell us what your problems are and how we can help you. And that's what the challenge is, and that's where innovation is. And now I would like to have a very innovative session, like an interactive way. So if you have any question, please feel free to shoot at us. More than happy to answer.
We will have a team, first we will have a demo.
Sure.
Hello.
So we have Manu J. Nair from Ethereal X who has joined us for the session. Thank you so much, Manu, for joining us. Sir, you can continue, Rajiv, sir.
Manu, can you just give a brief introduction of yourself and how and what is your view on about that satellite manufacturing and design, and then we'll open the session for the Q&A.
Good afternoon, everyone. This is Manu from Ethereal X. At Ethereal X, we basically build reusable rockets, and we are right now building the world's first fully reusable medium lift launch vehicle. And though I'm just filling in, I think it is very interesting. This is a very interesting subject for us to have a conversation about, which is innovation in spacecraft design, right? I mean, when you look at innovation in spacecraft design, you can primarily kind of put innovation into three metrics. One is in terms of materials, then you have propulsion systems, then you have the function, the very function it serves. So I think advancements in terms of any of these three aspects is something that will take, or let's say pave the way for better exploration in, and in terms of extracting as much power as we can from space. So for example, let's talk about the function of any spacecraft for that matter. One, we can talk about areas like configurable satellites, right? A single satellite that can perform variable functions, that has various levels of, let's say you have hyperspectral combined with, let's say, surveillance and whatnot. And that's one area. Just in the interest of time, I'll keep it quick. And then you have satellites with SDR, which is software-defined radio waves, right? So instead of using your hardware, you end up using the softwares to define, decode, decompute, and compute the radio signals. So this kind of makes your life much easier. Also reduces the weight of the satellite to a large extent, and the others in terms of materials. Materials is an endless area for innovation, and the other one that we spoke about, one of the key things is propulsion systems. When we talk about spacecraft, we often think of just satellites, but we need to also think now further in terms of other spacecraft, such as in-orbit servicing spacecrafts. When we talk about in-orbit servicing spacecrafts, it includes in-orbit refueling, fueling stations. You have satellite buses that perform the function of just like a bus here. Once you do a single orbit injection, a precise orbit injection is then later done by satellite buses, which further take those smaller satellites within the bus to the desired area. And I think more and more of these, let's say, in-space services spacecrafts, when they come in, it also makes the launch vehicle dynamics a little easier. It makes our lives easier as a launch vehicle manufacturer or a launch service provider. And the other thing is deorbiting services and deorbiting spacecrafts, which is also something that we need to very carefully think of. Because one of the prominent things when we talk about debris or bringing all of these non-functional satellites down, it is not a viable solution for us to have something like a net and capturing them and all of that. Instead, we need to have more agile technology, something more solid, like what we're suggesting would be something like a second stage of the rocket, which also performs the same function as that of a capsule, where you do not disengage your fairings, or you do not let them go. Rather, you capture the satellites or spacecrafts which are not functional anymore, and you deorbit them. And this can also be done because with reusable upper stage engines, you're doing several orbit injections. So I think there's a large avenue for us to go ahead and do innovation in terms of advanced spacecrafts and design, and where we are now looking towards doing the now that we have also signed the Artemis Accord, now that we'll be taking part in several of those missions. We need to keep in mind that we are competing with or let's say we are going head on with the global space innovation metrics and ecosystem, which means every area of development must be cutting edge. So yeah, I think I'll leave it at that. Thank you.
Thank you, Manu. So I think we'll open up this discussion. Initially, I would like to have a few questions, and I'll ask a panelist to develop on it. My first question is basically, we are, I was very much enthusiastic when you say LEGO mode of that what you call satellite building up in the space. But it is having a certain limitation and certain what you call criticalities, because in LEGO mode also, when you are assembling in that in space, docking and then interconnecting is a challenging task, isn't it? So economically, will it be viable to have a LEGO mode in space?
So let me answer this one. Because this was demonstrated already by Japanese companies in space station.
Yes.
They had a docking station on Kobe, and they did the full configuration. Yeah. So some of the American companies, they took that same concept, and I have seen that. Actually, I have been to the factory. I have seen the model, and those, exactly I had the same question, like how do you control the standard interfaces?
Yes.
And how do you go to incorporate into this one? So what they have developed is a docking mechanism, exactly what you said. So those are the small blocks, like they are cubes, exactly like a Lego, they are cubes. So they launched like a one satellite, one cube is equivalent to, let's say, 20U to 30U.
Okay.
So now you say, okay, I want, let's say, 300 kilogram satellite.
Yeah.
So accordingly, they are going to add 6 or 8 cubes. So that will become a one building block. In the middle, it will be all empty.
Yeah.
So in the middle, that's where they have cylindrical payloads on antenna or reflectors, whatever they want to do.
Yeah.
That will be on the top of it.
Yes.
So it goes right in the middle in the space. It docks it, and then the interface kicks in. Yes, inherent risks are always there, but that's the challenge we have.
For ISS and all, like a station purpose, LEGO is really a very good model. But when we come to like a communication satellite or US, we are coming, no? Because this all satellite should have a autonomous navigation to take care of a perfect like docking. So it is slightly costly a business to have a each LEGO block to have a navigation.
No, there's only one standard navigation, because when they all connected, when they launch, like say the building block is the one standard configuration. So that has all the star tracker, navigation, GNSS, everything on board, AOCS, everything. But the only thing missing is the payload, the communication payload and the reflector.
Yeah.
Because that will depend on the what you're covering, what type of band you have, and that will only depend on that part. And that's what's going on. The rest of the like AOCS and other things are there. Reaction wheels and everything is there in the building.
In the main
yeah.
building block.
And surprisingly, the cost is like they are much less costly than compared with the other traditional satellites.
Yeah.
And it was like 1/4 of the cost of a one block.
Yeah. So the LEGO blocks are actually launched separately, no? From time to time they are launching it and they are going and getting it docked.
There are two ways. Like one, if they know initially, okay, we need to have this satellite, they will launch all 4 or 5 cubes at the same time.
Yeah.
But in the future, if you want to expand it, then you can add additional CubeSats and the cube Legos, and they will attach onto it. And then you can inject or extract the old payload, and you can put a new payload.
Okay.
And every 5 years, you can change the payload if you want.
Yeah. That is the one more point. You are taking 5 years, like you said about that life of the satellites, like 18 years to 20 years. Do we really need that kind of life to our satellites? Because the way we are changing and the technology is changing. This technology today, what we are talking now, will be obsolete in another 2 years. I won't say even 5 years. 2 years, it will be totally obsolete. So is it worth it to even talk about 20 years from now or 18 years from now and invest in, and then ultimately like it will become a dead weight there, because you are not going to utilize anything out of it.
If I would be, I would give them 2-year life.
Yes.
Because for me, it's more beneficial.
Yes.
The more satellite I make, the replacement is better for me. Yeah. But the problem is that now, like there are 2 parts. If we are talking about the LEO, you know, the LEO is only 2 to 4 years.
Yes.
So they have to replace it anyhow. So it doesn't matter. So second part is if you're talking about the GEO, right now, most of the operators, they are no, if you look at the history in the last 3-4 years, there are less and less GEO satellites going up.
That's correct.
The reason is because the investor is not ready to invest into this one.
Yeah.
And they want to have the return of investment, and they want to have a long-term sustainability.
Yeah.
So that's the reason when any operator, and he wants to have a satellite, he would say, like to say have as long as life possible. And that's why we have in-orbit services, we have life extension satellites, and then we have tugs even now to do those sort of things. So these are the commercial related activities. For us, if I would be, as I said, I would be replacing every 2 years.
Yeah. Another thing, aspect is like in space production, when you are talking, manufacturing, it is actually having some limitation. Because when you are going up in the space and utilizing the whatever resources are available, because most of the resources you have to carry from the Earth itself. that whatever metal powder or plastic or whatever you really need it, and you will be utilizing only mostly the 3D, that additive manufacturing technology only to do that. So with that, you will be able to make few things only, like you will be able to make structures, booms, or maybe for example some antennas, but literally you will not be able to actually generate a payload there. So how you really, like we see that in future, when we are talking from 2 years from now or something like that, to build whole satellites payloads also in space, what will be the requirements?
So one of the key area right now, the scientific community or the exploration or all the people are working on for the lunar gateway. I give you an example.
Yes.
On the lunar gateways, there are going to be different modules. So each module will act as a different type of entity on board. So in that, they will have the capabilities to do the manufacturing and develop the new payloads and do some R&Ds over there. The similar they are doing in ISS, quite similar to that. So I agree to some extent that in orbit manufacturing, right now, as I said earlier, it's only focused up to LEO.
That's right.
You can't go beyond that right now because of the limitation we have, and it becomes more costly if you go to the further beyond LEO orbits. So that's why there are limitations are there, but the scientific community, universities, and research organizations, they are very heavily involved right now on coming up the in-orbit manufacturing and starting with the Lunar Gateway projects.
In fact, it's a very interesting question, because in space manufacturing, when we think of in terms of just the structures part, or let's say in terms of developing the payload part alone, but one of the key areas where in-space manufacturing really comes in is in the pharmaceutical and the medicine industry, where microgravity serves a very good purpose because of how fluid moves or behaves in microgravity. And when we talk about in-space manufacturing, I think the industry is actually looking towards having more manufacturing of those pharma grade and aerospace medicine grade manufacturing also being done on a large scale. And there is this company called Think Orbital. They are based out of the US. And they have partnered with Madari Space from Middle East. And you'd be surprised how they are building their habitable modules, which can also be turned into labs. So they have these honeycomb structures, the hexagonal structures taken up, but these are taken up in a stacked fashion. And they just have one robotic arm, which actually is a telescopic arm as well, which comes out of, reaches out of the bottom and automatically assembles these hexagonal structures into a ball. Now, then it has the ability to flip, and then it goes inward, and the bottom lid shuts, which means you create a safe a safe haven inside, and then there's laser welding done from within. So I think with a little more innovation in terms of approaches like this, the in-space manufacturing can actually do a lot of things.
Like a habitat or something when we are like planning there, no? This really will be a game changer. Because there means we need not to carry anything in like compact mode and go there. Whereas we ourselves can go and there make as in whatever design we really want to do it. But what you are telling, pharmaceutical area or even agro area, basically that is not business for a satellite. Basically that kind of experiment or that kind of like production is good for a station only. So that because you have to bring it back. Yes. Nothing you are likely to keep it there. We have to bring it back so that it can be utilized here.
Correct. These are manufacturing systems which need to have their own modules. So and since we are talking about the spacecraft design of the next decade, we need to be talking about all these reef modules and all these advanced modules which are actually going to do in situ manufacturing of not just the payloads or satellites per se, but also the various avenues where that we can actually bring it to.
You had developed something about AI. What actually really I want to know from Gurvinder is satellite manufacturing, that particular manufacturing in space. How much like AI can be involved to bring out a tangible output from that, which will be useful for this community?
So it's a building block. Let's go back to again. I've been lucky enough to be part of the Canadian Space Agency's Lunar Gateway program, where Canada is contributing the Canada arm, which we use in ISS, and now it's going to be used on Lunar Gateway. So as a part of this whole Lunar Gateway, so one of the concepts when we started was to have AI-based training, like how we're going to have AI-based manufacturing first.
Yes.
So we did it on the ground. So we created artificial intelligence-based modules where you had a head-up displays, where these scientists and the students, they were able to visualize as in the space, and how they're going to do the manufacturing in space, and how they're going to work. Although it's not exactly the same 100% result, but at least it gives an idea how it's going to behave and what the output would be. So the artificial intelligence-based algorithm, they came up with the results, and sometimes they say, okay, this will not work, this will have these negative consequences. So based on that, then the researcher, they improved, they developed, and that's how they come up with the different modules, and how the modules will be integrated and built in space. And that's all based starting from artificial intelligence-based module. And then when it goes in the space, and they're going to use the same module which was tested on ground, and then it implemented on the space. So this is how it works. So one thing I want to add about the medical, what you said, I'm not so sure if you are aware or anybody is aware of that in today's world, most of the medical testing what takes place, they were done in International Space Station. Like if you ever happen to be in Canada and come to visit to Canadian Space Agency, we have a big museum. In that you can see the whole collection of all the, including the blood sample, blood testing, blood pressure, all these technologies were developed in space and then brought to the Earth, including the blood, how you take the blood out and then how to do the blood transfusion. There's a lot of technologies which were developed in space. Because I remember once I was flying and I had a heated debate with some gentleman that why every agency in the world is spending millions of dollars on the space. What I'm getting in return. So I had to spend about 2 hours during my flight just to lecture him that everything you use today, from plastic, metal, and there is so many other byproducts which we use today, they were developed in space and then brought back to Earth because we tested in and we developed the properties and we developed the algorithm and then we were able to replicate on Earth, and that's what we are using today. And that's again a socio-economic development impact on the society today.
As I said, a station, this thing is really beneficial, but we don't talk about the satellites to have that kind of thing. Now, another question is what I see, like, because now we are in 2 days from now, we will be visiting Moon. We are on the voyage to Moon. And in future, there are so many talks are happening, and China and America, they both are also now planning to extract that lunar surface and make a station from there where a deep space mission can be possible. So in that, our satellites or whatever like spacecraft which we are launching in future must be able to take the resources from the lunar surface, convert them into a material for production, make the system on their self, and then go ahead. So that like that, it is like a base we will be creating on the lunar surface just to have our next launch station from there.
So tomorrow at 4 o'clock, I will be speaking on this one.
Okay.
And I have a full session on this one. As I said earlier, that we are part of LSIC, Lunar Surface Innovation Committee. That's a Johns Hopkins University and NASA. And I invite all of you to be part of this, and anybody can be member of this. So the best part is that you don't need any clearance or anything, and some certain parts you will have full access, that you can see all the presentation. They do every week 2-3 presentations, and it's a lot of technical detail and data. So tomorrow you can see that I have some slides where I can present to you. Like we are working on 3 different projects. One is the concept of a lunar colony, mining colony, the life sport involved around it, and how the in situ mining will be done, and how the extraction will be done, and then how they will be brought back to Earth. So there is a whole eco life cycle. So tomorrow I can share that slides with you.
Our spacecraft design has to be to take care of it,
Take care of
go
that,
to the lunar surface,
and bring
do
back.
the mining,
Yeah,
collect
bring
the
back.
sample or whatever
Yes.
material really
Yeah.
we are interested in, and to bring it back to the
Yeah.
Earth.
So, sorry to cut you, but as a part of this one, So with Leicester University in UK, so we developed a small metallic tubes. They are steel tubes like this size. So on the LTV, we have a robotics arm. A robotics arm has like a finger like this, and those fingers will drill the hole in the surface, extract the sample, do the analysis, or take the sample as it is, seal it in vacuum, and bring back to the lander. And the lander will act as a bring back to the Earth. So those spacecrafts are reusable spacecrafts, and that's what we are talking about. That will have to be reusable spacecrafts where we can use multiple time to have its cost effectiveness. And that's why it becomes important that we have onboard propulsion system strong and power enough to bring them back. And that's what I said earlier right now, that LSIC, one of the group is very much focused on non-radiative propulsion systems. So radiative, nobody wants to go into that direction. And now coming back to you touched base a very good point on the surface, the lunar surface. So I'm sure you might be aware of it or no, but if I may ask, anybody knows what is the main attraction? Everybody's going to the south side of the moon? Why everybody's going to the south side of the moon? Water. Sorry? Water. Nope. Nope. Anybody? Why Chinese are so desperate to go to the south side of the moon or dark side of the moon?
Material. Not really.
There are our moon is full of rare metals. Any specific?
Uranium and thorium.
Sorry? No. Helium. They are going after helium. Because helium is supposed to be the next source of power generation. So everybody is going after that. And there is a helium, abundance of helium on the south side of south side of moon, sorry. So just to give you a context, I
think I have heard that nuclear material also is available in abundance. And Chinese interested, actually Chinese for that only.
I don't know if you read an article about a month ago. There was an article from Chinese.
Yes.
And they extracted that helium and then they were going to use it. Why I'm saying it, because about 10 years ago, I had done some research and I did a paper even on this one. So for about 100 gram of helium, as of today, we can provide the power to the entire state of New York for about 10 years. And in today's value, that 100 gram cost about $2.4 billion. And there are two companies right now, one is in Russia, one in Germany. And those have mastered the processing of the helium to process it and use it for the generation of power. And there was an article written by a professor from Chennai University, and I think it's about 10 or 12 years old. He has written a very nice paper on this one. And he was the first person to actually pinpoint the helium extraction, use helium for the use of electricity and power generation. And that's the main attraction why everybody is running after this one. So water is, that's one now it's the old story because water is already found, so they know, okay, water is there. Now let's forget, let's find something else. And water, I'm telling you that I was a part of this about 2011. We started a company in Luxembourg named Ramaspace. So the whole purpose was to extract the water from the asteroids. So we did a successful demo, but after we couldn't get the funding because nobody was interested at that time. We gave them an analysis, like to carry 1 kilogram of water at that time was costing about $18,000 to International Space Station. I'm talking about 10, 12 years. Now it's much, much cheaper. While extracting the water from asteroid was costing us less than $6,000. So we did presented all the data at that time. The people were not ready because it was too way advanced than the time was. So that's why water is there, yes. There's a lot of possibility for water generation, but scientists are more focused on the power generation because that's what is creating a lot of issues with the environment or something like that. So you can fossil fuel and everything getting the lesser dependency.
Let's come back to our main topic, what we are actually sitting here, is a satellite production. Now I think it is time we open it for that Q&A from the audience. I hope that there will be a lot of questions. in their mind. So I welcome, yeah, please.
So my question is very fundamental and basic. What stops the current space industry from manufacturing satellites at scale in mass, like mass production of satellites? Like we are mass producing the cars, washing machine, and cell phones. And why we are not doing that for satellites?
I think I did answer already on this one. When I asked about manufacturing 4, it's already in the process.
My question is like we are launching Starlinks.
Yeah.
My calculation shows like they are producing 1,000 satellites per year to maintain their number of satellites that they are orbit. And it's been doing, they are doing it for the past 3 to 4 years. And I see there is that trend, it has not been transferred to the other parts of the industry even now, why they are.
Yeah.
So I'm asking specifically why it is not able to penetrating the other spacecraft manufacturing domain. Like there are guys doing that. Like SpaceX is doing that already. And why, for example, why ISRO is not doing that, or why any other company for that matter is not doing that?
It comes a priority. What priority you have? What objective you have? Long-term visions you
Right
have?
now, like ISRO, if you take, no, we do not have that kind of concept there, because this has been now, and the new space policy, it has been left with the private players to come forward and provide this kind of support. So whatever like this kind of Starlink or whatever OneWeb is kind of constellation we are talking, no, we expect actually industry to come forward, even to cater for Indian requirements, Indian peninsula requirements, etc. They have to come back, and there is possibility that is nobody stopping anybody. It is only the requirement. How much, how many are required, and how you are able to place them in a constellation. Because launching a satellite also is a costly business. Manufacturing satellite is a costly business. Then launching them and maintaining them in the orbit, if you have utility of it. If suppose you don't have a users, just launching a satellite, keeping it in an orbit is a really useless loss of money. Understood? So that way you have to have users who wants number of satellites, maybe 500 or 1,000 satellites in orbit over Indian peninsula to cater for the requirement of India. And I know that this is going to come. Not today, another 1 year from now, lot of private players are in that mode. They are planning to go and have this kind of their own constellation. First thing is that they are now nascent stage, no? Most of the people are now only thinking and coming up with the smaller satellite and launching in LEOs, and they have to see their performance, and then only they can duplicate it in multiple numbers. So they will do it, surely.
It's a demand and supply.
It is demand and supply.
Simple as it is.
And supply
So
should be like useful.
exactly.
It has to bring money. It's an economy.
So-
Basically, everything done by economy, not like for that scientific achievements or those things we now go for that industrialization, no? It's purely for money.
So we are doing like for example, OneWeb, and they are using small antennas. They are just like this size. So on each satellite, there are 12 by 12, 144 antennas in 12 constellation of 12 satellites. Each satellite has 12 antennas. So right now, in Montreal, where I used to work, we produce this as a mass production. It's a mass production done. We are not doing as a piece by piece. And if you go there, we have a hall like this, and everything is robotics. Nothing is being touched. Even from, we take one big piece of metal, like aluminum, and it goes through a CNC, then laser machining, the orientation, the beam forming, shaping, and check out. Everything is done automatically by the different stations. And similarly, like what I said earlier, in Berlin and in Leicester University, we are going to come up online by September, where you can see automatic production like cars will be taking place, where we can have 200 satellites per year to up to as much as you demand you can give. So it's there, technology is there, but people should be ready to accept it. Yes, it's a proven technology, somebody has to invest in it. Like for example, you're talking about Starlink. If I'm going to offer any service to Elon Musk, he will never accept it. Because what he wants to have everything fully integrated in his own in-house. Do you know he's not buying anything from outside, anything? Everything is fully integrated in his own premises, including propulsion systems, lasers, and everything. I have met him, I know they're half of the company. So we did a lot of presentation material, but his answer was complete straightforward. No, we will do everything in-house. So similar, this is a costly investment. Once he sees that this is being accepted by the industry, it's been proven, has a heritage, then he may buy that, layout and technology, bring it in, and start using that mass production. So you want to add something?
Yeah, I think I'll stick with the supply versus demand. But again, I think, in my opinion, also the supply will also change the demand. It's not all the time that the demand is where the supply comes in. But when you also push in and offer people, people end up realizing and taking the services. Like we didn't know the reusable rockets were a solution at all. It was basically a myth. Same way, when you provide satellite solutions which are much cheaper, it'll automatically come in and people will avail those services, provided it is going to the last mile. Now, as far as the mass production of satellites goes, the capability is always there, but again, if you're going to look at a scale where we are manufacturing thousands of satellites in a year, which means you're almost talking about the gigafactory, which is a very expensive affair. So unless there is a right motive for an organization or a nationalized space agency to spend that many millions of dollars to set up a gigafactory, they would ideally not go for it. So, but on the other hand, when it comes to a private player, it is a question of money. Do we have the money to set it up and put it in orbit and wait for people to avail the services? Most often, more often than not, the answer is no. Only billionaires or a multi-million-dollar agency would have the ability to do that. And coming from if it's going to come from a nationalized space agency, they would rather wait for the demand to build up before putting that kind of money into it. Which I think that hopefully answers your question as to why we do not have the mass manufacturing in place.
That is going to change. That is for sure.
My question is more from the Manu's perspective.
Yes.
Just because it's not smartphones, enable the apps like Zomato and Ola to thrive. So that the standardization of space.
No, there's a number of users, no, because that all whatever you see, that whatever disruptive things are coming, if there are users, there people are coming forward and they are taking up like that. So that satellite also is like ultimately, like I think in morning session we have discussed, and our honorable governor also was talking. No, now you name anything, it can be solved through the satellite from the space. Anything. Now, earlier we were having limited only for communication purpose or Earth observation purpose, remote sensing, those things. Now you talk anything which is solved by the space. Like we are now direct to sell also, that direct to sell. That kind of concept. Now new things will come, and then demand also will grow. When demand grows, supply has to come there. No? Supply has to meet, so then people will come forward. Right now, like if you look in this ecosystem, many players are not there in India. Nobody really coming forward for this kind of mass production and those things. But things will change when economy, like when we say no, it is having economic viability, people will come forward. Because why shall I invest? That is the question, no? I should get back the return. Return comes when it is having a business model. So that these all are interrelated. So that way only things will proceed. But the way that the space economy is now growing, no, this is going to happen.
End of the day, it's money.
Money.
Whatever you can say, you can hold this way or this way. End of the day, it's money.
That's
if
why
you have money, that generates the whole idea.
That's why when you asked that question, my answer was this.
Yeah,
I
nothing
don't know
else.
if you saw it, I just did.
Anyone? Okay. Yes, yes. Okay, go ahead.
I'm a law student from Royal School of Law, and just as a curious law student, as we are talking about manufacturing and development of satellites and spacecraft, what are the intellectual properties, implications, and issue as a manufacturer you are facing?
From your perspective or from my perspective?
We have both a different perspective. No?
Yes.
We are like a government
It's a government agency as a commercial.
Because my requirement will be different.
Yes.
Like my use also will be different. IP on
Yeah.
those things also we have like a close guarded those
Yeah.
things. We will be very much worried about those IPs.
Yeah.
Whereas when you go for like commercial use of the satellite, I don't. He
So-
will be able to answer it more.
So commercial point of view, I can tell you that we, like for many years, we had decided And it sort of makes sense for us at least, for the commercial point of view, and even from previous companies where I had worked. And most of the senior executives, they were of the opinion that we will not go for patents, number one. Because once you do patent, it's a public-private. Then anybody can do, you change a screw, it's your property. Nobody can challenge it. So we never went for a patents or anything. So we kept it as a industrial intellectual property in-house. So that's much easy to control rather than to putting in public domain.
But sir, don't you think that as we do not put that thing into the public domain, it will eventually, affect the end users? As in, these technology itself, as sir said, would be within a year or two, would be obsolete in nature.
You are looking from your perspective. I have to look into my perspective, because if I have to develop some technology, I have to spend millions of dollars. Or I'm going to expect it. If I'm going to put on public, I know public say, hey, I want to learn what you're doing, because I want to improve it. Come on. Bullshit. You're not improving. You want to make money out of it. Let's be realistic. Like everybody wants to learn what you're doing, how you're doing, so I can reverse engineer it and I can do it, make myself money. Why should I do it? Why should I kill my own business?
And
Less
most of
than
the component will be actually now mostly COTS only.
Yeah.
We are not going to innovate and design or coming to that. No, then only question of IP comes in. We are like even in this now ecosystem, we are actually
Integrator.
trying to get things which are available in the market and then assemble our product
We are integrator.
so that we can spend less money, get maximum output.
So I think from a commercial point of view, most of the components which would be are mostly standardized, right? So now you have a basic framework which is readily available for which you do not require a particular IP. So IP kicks in only when you're providing a very specific function, which is something that you've innovated as an organization. So for example, that's where he said, if I'm going to make money out of something which is unique that I'm going to do, then I cannot let it be in the public domain. The rest of it can be our standardized components that I can source it from elsewhere, right? Which is one of the reasons why even if you, a basic example would be SpaceX. 97 to 98% of the patents that they put outside are not what they use on their rockets, right? Those are patents filed for just for the sake of misleading you into what they're actually doing, and it has been accepted by them. So
Diverting minds, that's it. Diverting yourself to look into that direction, and they will continue to these things.
Small satellite trend, it's posed by the Starlink and it's coming up. Is there any reversal in trend is happening? Because in the last 3 days back, people in text that they avoided almost like 25,000 collisions they avoided in the 6 months time. So I think there are not big competitors of that kind of a number of satellites people are not yet put. Then it is going to be a real is there any at least one person who like bulldozers? But then is there another bigger companies who declare the constellations are they costly because we are interacting so much with the other industries like that? I asked the question.
I think let me answer this question frankly and openly. What you see is not true. You see today's Starlink, but anybody has not asked or challenged him to see his balance book. He's losing money. He's getting the shareholders' money, has reinvesting it. Today, I give you example when he started originally. Starlink when was launched about 2-3 years ago when they had first launch. So the whole concept is with the antenna and the terminal, and per month fees was like let's say $500, $499, and plus you had $1,900 per month, something like that. And today, because I know these people very fairly close enough. The VP and CEO of Starlink, he used to be the head of SpaceX. So I know him personally because we use them for many, many launches. So in-house, that's costing them more than $2,000-3,000 per set. So he's offsetting the cost to kill everybody else who's going to come on board. So now I give you another example, Telesat, for example. They have been struggling for the last 4 or 5 years to raise the funds because they cannot maintain a viable economic business case. And to me, honestly, I don't think so there is anybody who has been able to project a viable financial business case, a profitable financial business case for these LEO constellations. Everybody's talking, there's a big hype. When the bubble bursts, then who's going to suffer? The whole industry. Because there will be no more investor left to invest in anywhere else. People don't think about these things because they see the news. Oh, they have launched 3,000 satellites. They have launched 4,000 satellites. Other thing which they don't realize that these satellites have to be replaced every 2.5 years. That's additional cost. It's not free. And do you think he has enough return of investment to replace all these satellites in 2 years and make enough money? And 2 weeks ago, I was in Indonesia because we have an office in Jakarta. So I was discussing some of the regulators. They didn't give him the landing rights. The same thing happened in India. He came here, he could not get the permits and permissions, and now something's going on, but it's difficult. So in many, many countries, he has not been able to obtain the landing rights. So if he doesn't have even landing rights, how he's making money? Nobody is able to justify. I have not seen anybody who's been able to tell me, hey, they are making money or they are in green. They are in red. So it's a concept that he has created so much vibe that everybody is saying, oh yeah, Starlink, Leo Starlink. And they're saying, oh, Amazon, this and that. But end of the day, they are not making money.
But I think that is in interest of actually building a supply chain, which can actually become much cheaper. It is because of these guys who actually bring down the cost and do it at a much, though their in-house costing is much higher. So when you in-house develop a supply chain and when you source it at that cost and you further bring your cost down, you are in fact trying to bring, I would say instead of killing the competition, I think in a way it is to bring more people to do the same thing at various costs so that the supply chain really kind of builds and slows down the actual cost.
Except the because as I said earlier, except the SpaceX, they are not developing any supply chain. They are having their own supply chain. So they are not helping the industry, they are helping themselves. And end of the day, when I said earlier, because I have studied their business case very well, and they have to replace 2.5 years every satellite. And as the article I read also said, article that 25,000 maneuvers. Right. So that's a big costly exercise. And, you know how much operational people you need, how many ground staff you need to do this, do the station keeping, maneuvers, and all these things.
In fact, LEO will soon be regulated in one way or another, because right now orbits are being treated like real estate. Everybody's pre-sanctioning one particular part of the orbit into their own system. Now, be it a private agency such as SpaceX, in one way, when you sanction that part of the orbit, you're not letting anybody in there. So, in one interest, nobody really knows what the real goal of Starlink or Kuiper is really going to be. We know, we are being told that it is for network, but I don't think it becomes that simple when you're putting thousands of satellites into orbit and you have so much of government funding into it. So I think it's a little more complex in terms of having to define.
Won't be actually in public domain won't come because things are that the satellite will have always different uses also. Yeah, that's correct.
May I ask, Manu, you talk about developing the world's first fully reusable rocket. So
Medium.
they come, sorry?
Medium.
Medium. So yeah, that's what I wanted to know. How many stages you talking on, what terms, and how far along are you?
Yeah, so we are in, right now we are at TRL4 of our propulsion systems. And what we're essentially doing is to try to build another, the Department of Space initially suggested that we need to capture at least 10% of the global space market by 2030. And we cannot do so in the launcher segment if we are going to operate with smaller rockets. It's imperative that we move towards larger vehicles. That was one of the fundamental philosophies when we started out as well. As to when we started and how far along we are, as a team, we began the ideation back in 21, and it was me and two of my other co-founders. So one person is from ISRO. He was in ISRO for 10 years, almost a decade plus. And I'm a scientist astronaut graduate through the NASA Space Flight Opportunities Program. And my other co-founder is Prashant. He's worked with several private place companies to build it. We officially incorporated in 22 May. It's been 14 months, and given the development we have, we have the fastest growing launch vehicle company in the country. We just recently closed our first round of funding, and we were the first startup in history to have been invited for the Launchpad program by Beyond Gravity. They're what ISRO is to India to Switzerland, and their specialization is in reusability of fairings. So we recently were invited for that, and we were the only startup in history outside of America and Europe to have been invited for that. And we learned how they do the reusability with the fairings, and they've also worked with SpaceX and how they go for the materials, the manufacturing techniques associated with the fairing design and all of it. And we are looking to do our engine testing this coming November or December of the upper stages engine, which is one of the most unique setup that we have for the reusability of the upper stage. It's a 40 kilonewton engine, RP1 LOX. We can do about 16 orbit injections with that. And we are doing the injector testing in just about 2 weeks now. On 29th is when we have scheduled to do our injector testing, but it'll be more of an internal affair. And we are planning to do a smaller vehicle launch, a single engine mounted launch, to just check most of the flight software and to check the propulsion systems and the relanding systems in Q4 25 or Q1 26, and a full-fledged launch by 27 Q1 or 2. So that's the test launch. So that's the timeline. Yeah, a vertical launch system. It's a 2-stage to orbit vehicle. It's designed to carry 24.8 tons to the low Earth orbit in expendable configuration, 22.8 tons to the low Earth orbit in partially reusable configuration, 8 tons to the low Earth orbit in fully reusable configuration. And GEO, we can take 10.8 tons in expendable configuration and 8.6 in partially reusable configuration.
I think one last question. I think the gentleman has one last question.
Yeah.
I think politically correct or diplomatically, I should say no comment. Because, if China is going to do, first of all, there's no worldwide market. They can't just sell anywhere outside China because US, anything, anywhere. So it's a government funded, they can do whatever they want. When you have a $3-4 trillion in your reserve, you can afford to lose a couple of billion. They don't care. And they have to develop their industry. That's what they're trying to do, to showcase, hey, yes, I am more powerful than you. Nothing more than that. And if you look at, I'm just going to give a simple example. They have developed so many cities, they call like the smart cities or super smart cities. And if you go, 90% of them are empty, not even a single person is living there. I've been to few cities in China. Not even a single soul. But it's so beautifully built, everything, even these roads are solar generated, and they create the solar power, and you can recharge everything just from the roads. That technology, but nobody's living there. But they showcase it to the world. Yes, we have this. The same thing here, we have launched 30,000. But commercially it's viable? No.
Thank you very much. I think it's time to wrap up. So I thank Gurvinder as well as Manu. I think we had a lively session here, and audience was also really live. And I think if you have any query or any questions, we will be having outside, and then during lunchtime things can be sorted out, talk about it. I think it's better to now we wrap it up.
Yes.
Thank you very much. Yeah.
Thank you so much, sir. Thank you everyone for staying here. I'm sure we've had a lot of food for thought. It's time to have some food now. So we'll break for lunch. Thank you so much, sir, for taking us through the session. I'd like to thank Rajiv, sir, for moderating it, and also Gurvinder, sir, and Manu for adding to the discussion. We will be reconvening at 2:30 after the lunch break. In this track, the next session is on next-gen innovations in the ground segment. We have fundraising, SPACs, and M&As scaling space business in the Oval Hall. We have demystifying Earth observation in track 2, and opportunities from multi-orbit satellite broadband in track 3. There's also a startup meet, which I hope you guys are aware about. We have a startup and investors meetup at 3:50 p.m. in Regency Ballroom 3. So yes, that's all the information that I had to share right now. We can break for lunch now. Thank you so much for the audience as well for staying throughout the session. Yes, we'll have a group picture, sir. And can we have a loud round of applause for our speakers, please? Thank you.